Hello students. Students, other chemical substances are divided into two categories. How many? Two categories. Elements and compounds. Pure chemical compounds, either elements or compounds, occur in three different phases, namely solid phase, liquid phase, and gaseous phase. When pure substance goes from one phase to another phase, energy change takes place. And because of that, we can calculate enthalpy change. What is the letter for enthalpy? H. Mathematically, we have seen H is equal to U plus PV. Or, in words, what is the definition of enthalpy of the system? Enthalpy of the system is the sum of internal energy of the system and energy associated with PV type of work. Enthalpy of the system is the sum, addition of internal energy of the system and energy associated with PV type of work. Therefore, mathematically, H is equal to U plus PV, where H is the symbol for enthalpy, U for internal energy, P for pressure, and V for volume of the system. We have learned H, that is enthalpy, is a state function. Therefore, we can find out enthalpy change, that is delta H. How to find enthalpy change? Delta H is equal to H2 minus H1, where H2 is the enthalpy of the final state of the system and H1 is the enthalpy of initial state of the system. Student, 1 is the number for initial state and 2 is the number for final state. Delta H is equal to H2 minus H1. Delta H is enthalpy change. H2 is enthalpy of system at the final state and H1 is the enthalpy of system at the initial state. Suppose our system is a chemical reaction. When system is a chemical reaction, that time enthalpy change is called enthalpy change of chemical reaction. See, on the blackboard, you will find enthalpy change of chemical reaction, and it is shown by delta HR. So henceforth, you have to read delta HR as enthalpy change for chemical reaction. Enthalpy change for chemical reaction, small r, written after delta, at the bottom of the delta, indicates the reaction. Delta HR, you have to read as enthalpy change for a chemical reaction or only reaction. Delta HR is enthalpy change for reaction. To learn more about enthalpy change of chemical reaction and different types of delta HR, we will take the help of slides and PPT. Let me allow to share the slides and PPT with you. Students, see, the heading of the slide. Heading of the slide is enthalpy change of a reaction. Reaction enthalpy. विद्यार्थी मित्रों, डिपार्टमेंट ऑफ केमिस्ट्री त्यातला मला जर ऑफ करायचा असेल तर काय होईल? केमिस्ट्री डिपार्टमेंट. डिपार्टमेंट ऑफ केमिस्ट्री म्हणजेच केमिस्ट्री डिपार्टमेंट. तसंच एन्थाल्पी ऑफ केमिकल रिॲक्शन, एन्थाल्पी ऑफ रिॲक्शन, एन्थाल्पी ऑफ रिॲक्शन. जर तुम्हाला ऑफ करायचा असेल काय बनेल? रिॲक्शन एन्थाल्पी. बोथ आर सेम. Enthalpy of reaction or reaction enthalpy. Symbolically, delta HR. R indicates reaction. Now, see, in chemical reaction, we have to write reactants to left hand side, and after the arrow, we have to write products to the right hand side. In short, in a chemical reaction, reactants are converted into products. Now, the slide it is given how to represent the reaction. Reactant state is the initial state, isn't it? And product state is the final state. Therefore, for a chemical reaction as a system, enthalpy change or delta H is equal to sum of enthalpies of products minus sum of enthalpies of reactants. What we have done? We have replaced H2 by sum of enthalpies of products. Why? Because product state is the final state minus sum of enthalpies of reactants. We have replaced H1 by sum of enthalpies of the reactants. Same thing is there. For a system, delta H is equal to H2 minus H1. 2 means final state, product state, and H1 means enthalpy for initial state. For chemical reaction, initial state is reactant state. So, when cysteine is a chemical reaction, delta H becomes delta HR. And how to find delta HR? Delta HR is equal to sum of enthalpies of products minus sum of enthalpies of reactants. Don't forget this mathematical equation. I will go to the next slide. In the textbook, same thing is given, but in the textbook, summation sign is used. So, delta HR, enthalpy change or reaction is equal to summation of enthalpies of products minus summation of enthalpies of reactants. Both are correct. You can write in words or you can write with the help of symbol. What we have learned? Delta HR. What is delta HR? Enthalpy change for reaction. And what is the right hand side of the equation sign? Delta HR is equal to summation of enthalpies of products minus summation of enthalpies of reactants. Suppose there is one question, define the term enthalpy of chemical reaction or enthalpy of reaction. To define the delta HR. In that time you have to just write this equation, mathematical equation in words. Same thing is given on this slide. You have to given the bold letters. Enthalpy of chemical reaction is the difference between sum of enthalpies of products and sum of enthalpies of reactants. Once again, I am telling you how by using the mathematical equation delta HR is equal to summation of enthalpies of products minus summation of enthalpies of reactants, you can write definition of enthalpy of reaction, that is delta HR. What is the definition? Enthalpy of reaction is the difference between sum of enthalpies of products and sum of enthalpies of reactants. That's all. Now you can write the definition. Now see the next slide. On the slide at the top, read the heading. Heading is standard enthalpy of reaction. Along with enthalpy of reaction, one more word is added, standard. Now, for standard, what we have to use? For standard, we have to use 0 after the delta H. When there is 0 after delta H, you have to use standard enthalpy of reaction. Delta HR means enthalpy of reaction. And suppose you want to represent standard enthalpy of reaction. Then what you have to write? Delta HR 0. And that 0 will come on the head of H to the right hand side. Once again listen. Enthalpy of reaction, you have to show symbolically delta HR. Is clear? Now, how to represent standard enthalpy of reaction? Delta HR 0, and that 0 comes on the head of H to the right hand side. We have to read 0 as the standard. Suppose it is given delta HR 0. How you will read? First you will read standard for 0, then for H enthalpy, then for R reaction. Standard enthalpy of reaction. How to go? 0 means standard, then H means enthalpy, then R means reaction. Standard enthalpy of reaction. Okay. Now, what is the difference between enthalpy of reaction and standard enthalpy of reaction? Standard enthalpy of reaction is nothing but enthalpy of reaction. But when the substances, means reactants and products involved in the chemical reaction are present in their standard state, and other conditions of temperature and pressure are also standard conditions. Listen once again. Standard enthalpy of reaction is nothing but the enthalpy of reaction. But reactants and products, the substances involved in the reaction are in their standard state. The other conditions, conditions of temperature and pressure, are also standard conditions. You know this, we can define the term standard enthalpy of reaction. That is delta HR 0. The definition of delta HR 0 or standard enthalpy of reaction is: standard enthalpy of reaction is the enthalpy change of reaction when the substances participating in the chemical reaction, that is reactants and products, are present in their standard state, and other conditions, that is conditions of temperature and pressure, are also standard conditions. Now, what is the standard temperature? Standard temperature is 25 degrees Celsius or 298 Kelvin. What is the standard pressure? Standard pressure is 1 bar. If any substance involved in the chemical reaction, either as reactant or product, is a gas, that time the pressure should be 1 bar. Pressure should be 1 bar or the standard enthalpy of reaction. For the standard enthalpy of reaction, temperature of reaction should be 298 Kelvin or 25 degrees Celsius. Suppose one of the reactants or products is present in solution form. That time, to get standard enthalpy of reaction, concentration of that substance involved in the reaction as a solution should be 1 molar. Concentration should be 1 molar. Once again, listen the definition of standard enthalpy of reaction. Delta HR 0. Standard enthalpy of reaction is the enthalpy of reaction when substances involved in reaction, substances taking part in the reaction, that is reactants and products, are present in their standard state, and conditions of temperature and pressure are also standard conditions. I told you the standard condition for temperature and pressure. Next slide will get that condition once again. See this slide. Thermodynamic standard conditions. For what? To get the standard enthalpy change of reaction. That is delta HR0. To get delta HR0, what are the standard conditions? Temperature should be 1298 Kelvin or 25 degrees Celsius. Pressure should be 1 bar if any substance involved in the reaction is in gaseous state, and concentration should be 1 molar if substance participating in the chemical reaction is as a solution. Let's hope you are getting this. Now we'll get the next slide. We'll see the next slide. What is the next slide? Next slide is heading thermochemical equation. What is thermochemical equation? Thermochemical equation is nothing but the balanced chemical equation of reaction, which also shows enthalpy change. The question is, what is thermochemical equation? Your answer should be thermochemical equation is the balanced equation of chemical reaction in which substances are present in their standard state, and equation also shows enthalpy change. Once again, I am telling you, what equation is, what is thermochemical equation? Answer must be thermochemical equation is a balanced equation of chemical reaction in which reactants and products are present in their standard state, and equation also shows the enthalpy change, that is delta H. Okay. Here the balance equation of chemical reaction, the coefficients मराठीमध्ये आपण त्याला म्हणतो सहगुणक. रिएक्टंट्स आणि प्रोडक्टचे सहगुणक काय दर्शवतात? नंबर ऑफ मोल्स. रिएक्टंट्स आणि प्रोडक्टचे जे सहगुणक असतात, कोएफिशियंट्स असतात, ते काय दर्शवतात? त्या रिएक्टंट्स आणि प्रोडक्टचे नंबर ऑफ मोल्स. आणि डेल्टा HR0 म्हणजे स्टँडर्ड एन्थाल्पी ऑफ रिएक्शन कशामध्ये एक्सप्रेस असायला हवी? किलोजूल पर मोल. किलोजूल per mole मध्ये. See the slide, read the slide carefully, you will clear our concept more nicely. Let's go to the next slide. Here, what is the heading of next slide? Standard enthalpy of formation. Listen carefully. We know standard enthalpy of reaction. Correct? Delta HR0. But all reactions are not same reaction. Some reactions are formation reactions. Some reactions are combustion reactions. Isn't it? There are also other types. When reaction is combustion reaction, that time standard enthalpy of reaction is called standard enthalpy of formation. Listen once again, all chemical reactions are not same reactions. Some chemical reactions are formation reactions. Some chemical reactions are neutralization reactions. Some chemical reactions are combustion reactions. So when chemical reaction is formation reaction, when chemical reaction is formation reaction, standard enthalpy of reaction is called standard enthalpy of formation. मग ह्याच्यामध्ये सिम्बॉलिकली दाखवताना फरक काय होईल? स्टँडर्ड एन्थाल्पी ऑफ रिएक्शन कशी दाखवतो आपण? डेल्टा HR0. फॉर्मेशन रिएक्शन मध्ये काय होईल? स्टँडर्ड एन्थाल्पी ऑफ फॉर्मेशन. त्या ठिकाणी जो R आहे त्या ठिकाणी F येईल. स्टँडर्ड एन्थाल्पी ऑफ फॉर्मेशन कसं लिहावं लागेल आपल्याला? डेल्टा HF0. स्टँडर्ड एन्थाल्पी ऑफ फॉर्मेशन डेल्टा HF0. डेल्टा नंतर डेल्टाच्या राइट हँड साइडला बॉटमला F येईल and F stands for formation. So delta HR0 means standard enthalpy of formation. Delta HF 0 means standard enthalpy of formation. आता स्टँडर्ड एन्थाल्पी ऑफ फॉर्मेशनची तुम्हाला डेफिनेशन लिहायची. त्यावेळेस तुम्हाला काय लक्षात घ्यावं लागेल, असा एन्थाल्पी चेंज ज्यावेळेस एक मोल सबस्टन्स त्याच्या स्टँडर्ड स्टेटमध्ये फॉर्म होतो, कुणापासून? त्याच्या कॉन्स्टिट्यूएंट एलिमेंट्स पासून, जे ते सुद्धा त्यांच्या स्टँडर्ड फॉर्ममध्ये असतात. आता आपल्याला इंग्लिशमध्ये पाहायचे, पुन्हा एकदा मराठी सांगतो. समजा तुम्हाला लिहायचे स्टँडर्ड एन्थाल्पी ऑफ फॉर्मेशनची डेफिनेशन. स्टँडर्ड एन्थाल्पी ऑफ फॉर्मेशनची डेफिनेशन तुम्हाला काय लिहावं लागेल, अशी एन्थाल्पी चेंज त्यावेळेस एक मोल सबस्टन्स फॉर्म होतो, तयार होतो, त्याच्या स्टँडर्ड स्टेटमध्ये, कोणापासून? त्याच्या कॉन्स्टिट्यूएंट एलिमेंट्स पासून, जे एलिमेंट त्यांच्या स्टँडर्ड स्टेटमध्ये असतात. हे जर कळलं असेल तर आपल्याला स्टँडर्ड एन्थाल्पी ऑफ फॉर्मेशन म्हणजेच डेल्टा HF0 ची डेफिनेशन लिहिता येईल. स्टँडर्ड एन्थाल्पी ऑफ फॉर्मेशन इज denoted by delta HF0. Now we'll go to the next slide. See, in this slide you'll find the definition of standard enthalpy of formation. ज्यात आपण पाहिलं की इंग्लिशमध्ये आपल्याला पाहिजे, standard enthalpy of formation is the enthalpy change of reaction when one mole of substance is formed from its constituent elements which are present in their standard state. Once again, I am repeating more correct words. Standard enthalpy of formation, that is delta HF0. Standard enthalpy of formation, that is delta HF0, is the enthalpy change of reaction when one mole of substance is formed in its standard form from its constituent elements which are also present in their standard state. I am repeating, so also repeat at home. Standard enthalpy of formation, that is delta HF0, is the enthalpy change of chemical reaction when one mole of substance is formed in its standard state from the constituent elements which are also present in their standard state. Okay, now on the slide one example is given, formation of CH4, 1 mole of CH4. Now what is the standard state for CH4? Gaseous state. At the room temperature, ordinary temperature, CH4 is present in the gaseous state. First 4 members of the alkane series are in the gaseous state: methane, ethane, propane, butane, at the room temperature or at the ordinary temperature. So standard state of the CH4 is gaseous state. Which are the constituent elements of CH4? Carbon and hydrogen. What is the standard state of carbon? Solid state. At room temperature, carbon present in solid state. So C in solid state plus 2H2 in gaseous state. Why? Because standard state at ordinary temperature, that is at 25 degrees Celsius or 298 Kelvin, is gaseous state. When constituent element, that is carbon and hydrogen, they are in their standard state, and when they combine to form 1 mole of CH4 in its standard state, that is in gaseous state, that time the enthalpy change at standard conditions is standard enthalpy of formation, and standard enthalpy of formation for CH4 is minus 74.8 kilojoule. With the help of an example, we have repeated the definition. So let's hope you have your understanding. Now, by using, see carefully the slide. See the top sentence. Calculation of delta H0 R, delta H, delta H R0, sorry, calculation of delta H R0. What is delta H R0? Standard enthalpy of reaction. उसको हमें कैलकुलेट करना है किसे फ्रॉम डेल्टा एच एफ जीरो यानी स्टैंडर्ड एंथैल्पी ऑफ फॉर्मेशन हम कर सकते हैं वी कैन कैलकुलेट डेल्टा एच आर जीरो दैट इज स्टैंडर्ड एंथैल्पी ऑफ रिएक्शन फ्रॉम डेल्टा एच एफ जीरो दैट इज स्टैंडर्ड एंथैल्पी ऑफ फॉर्मेशन कर सकते हैं फॉर्म कर सकते हैं लेकिन उसके लिए हमको दो रूल्स यूज करना पड़ेगा और दो रूल्स क्या है standard enthalpy of formation of every element is zero. Standard enthalpy of formation for any element is zero. कोई भी एलिमेंट लो उसके लिए स्टैंडर्ड एंथैल्पी ऑफ फॉर्मेशन क्या होता है जीरो हाइड्रोजन ऑक्सीजन ये किसमें होते हैं डायमोलिकुलर फॉर्म में वो एलिमेंट से इसलिए अगर हमको लिखना है डेल्टा एच एफ जीरो ऑफ सी एल टू तो जीरो आएगा डेल्टा एच एफ जीरो ऑफ सी एल टू का मतलब क्या हो गया स्टैंडर्ड एंथैल्पी ऑफ फॉर्मेशन ऑफ क्लोरीन एलिमेंट जीरो कार्बन कौन से फॉर्म में होता है एटॉमिक फॉर्म में होता है फिर अगर हमको कार्बन एलिमेंट के लिए लिखना है तो क्या होगा डेल्टा एच एफ जीरो ऑफ सी मीन कार्बन इज जीरो लाइक इट इज गिवन डेल्टा एच एफ जीरो फॉर एच टू इज जीरो डेल्टा एच एफ फॉर 0 for Cl2 is 0. Similarly, delta HF 0 for O2 is 0. Similarly, delta HF 0 for N2 is also 0. Delta HF 0 for carbon is also 0. So what is, in short, standard enthalpy of formation of any element is 0. Element की standard enthalpy of formation क्या होती है जीरो होती है and what is the second rule standard enthalpy of formation of any compound is equal to its standard enthalpy एक रूल एलिमेंट के लिए दूसरा रूल कंपाउंड के लिए standard enthalpy of formation of compound is equal to its standard enthalpy तो एग्जांपल देखो नीचे दिया हुआ है कैसे लिखेंगे कंपाउंड के लिए डेल्टा एच एफ जीरो फॉर कंपाउंड इज इक्वल टू एच जीरो फॉर कंपाउंड तो कैसे पढ़ेंगे स्टैंडर्ड एंथैल्पी ऑफ फॉर्मेशन ऑफ कंपाउंड स्टैंडर्ड एंथैल्पी ऑफ फॉर्मेशन ऑफ कंपाउंड इज दी स्टैंडर्ड एंथैल्पी ऑफ कंपाउंड इस तरह आपने पढ़ा है डेल्टा एच एफ जीरो ऑफ कंपाउंड कैसे पढ़ेंगे जीरो से स्टार्ट करेंगे स्टैंडर्ड एंथैल्पी ऑफ फॉर्मेशन ऑफ कंपाउंड इज इक्वल टू एच जीरो कंपाउंड दैट इज स्टैंडर्ड एंथैल्पी ऑफ कंपाउंड ठीक है ये दो रूल लिए हमने और हमने अगर नेक्स्ट स्लाइड पे गए तो उसके हम क्या कर सकते हैं हम डेल्टा एच आर जीरो निकाल सकते हैं किसी भी केमिकल रिएक्शन के लिए डेल्टा एच आर जीरो का मतलब क्या हो गया स्टैंडर्ड एंथैल्पी ऑफ रिएक्शन और हम यूज क्या करना है स्टैंडर्ड एंथैल्पी ऑफ फॉर्मेशन ऑफ रिएक्टेंट्स एंड प्रोडक्ट्स सी carefully on the slide. How to find delta H R0 that is standard enthalpy of reaction. Standard enthalpy of reaction is equal to summation of standard enthalpy of formation of products minus summation of standard enthalpy of formation of reactants. ये पढ़ने आना चाहिए आपको डेल्टा एच आर जीरो मतलब स्टैंडर्ड एंथैल्पी ऑफ रिएक्शन which is equal to summation of standard enthalpy of formation of products minus summation of standard enthalpy of formation of reaction. The formula use करना है student do you know while solving the numerical problem you have to write first which is the correct formula and to just write correct formula there is half mark. तो हर एक न्यूमेरिकल प्रॉब्लम सॉल्व करेंगे तो पहले हम कौन सा करेक्ट फॉर्मूला है उसको मेंशन करके उसको लिखेंगे और यू विल गेट हाफ मार्क. We go to the next slide. See, the textbook problem number 4.10, we'll see how to solve. Problem number 4.10 is calculate standard enthalpy of reaction. It means what you have to find? Delta HR0. Standard enthalpy of reaction. Delta HR0 आपको निकालना है, ये आपका टारगेट हो गया. Which reaction is given? 2C2H6 in gas state. C2H6 means actually ethane. 2C2H6 in gas state plus 7O2 in gas state. Reaction react to give 4CO2 in gas state plus 6H2O in liquid state. See the coefficients of reactions and products carefully. हमें coefficients use करना पड़ते हैं, and we have seen coefficients indicate number of moles. उनको यूज करके ही हमको न्यूमेरिकल प्रॉब्लम सॉल्व करना पड़ेगा. What is given in the numerical problem? The given things are standard enthalpy of formation of CO2 is given, standard enthalpy of formation of H2 is given, similarly standard enthalpy of formation of C2H6, that is ethane, is given. And what we have to find? Standard enthalpy of reaction, that is delta HR0 निकालना है. हमने अब जस्ट नाउ कौन सा फॉर्मूला दिया है? डेल्टा HR0 is equal to summation of standard enthalpy of formation of products minus summation of standard enthalpy of formation of reactants. उन्हीं को अलामत करो. हमें भी पहले क्या निकालना है? summation of standard enthalpy of formation of products. दो प्रोडक्ट्स थे, CO2 और H2O. दोनों के हमें क्या दिया है? स्टैंडर्ड एंथैल्पी ऑफ फॉर्मेशन. उतना लेके चलेगा नहीं, क्योंकि नंबर ऑफ मोल्स उनको मल्टीप्लाई करना पड़ेगा. So what is given next? See the next step. 4 into standard enthalpy of formation of first product, that is CO2. Why 4? Because there are 4 moles of CO2. 4 into standard enthalpy of formation of CO2. CO2 is the first product, plus 6 into standard enthalpy of formation of H2O. Second product is H2O, and see the number of moles for H2O, 6 moles. First part हो गया right hand side का, minus, see the part of minus summation of standard enthalpy of formation of reactions. There are two reactions, ethane and oxygen. What we have to do is the number of moles. Okay, so minus, see the in big bracket, 2 into standard enthalpy of formation of C2H6. Why 2? Because there are 2 moles of C2H6, plus 7 into standard enthalpy of formation of oxygen. Why 7? Because there are 7 moles of O2, and O2 is the second reaction. Just see the values. What values we have to write in the next step. 4 तो वही रहेगा. You have to put the value of standard enthalpy of formation of CO2 is given in the numerical problem. Then plus 6 into value of standard enthalpy of formation of H2O, which is also given, minus in second bracket. So this is the important part. 2 into value of standard enthalpy of formation of C2H6 given in the numerical problem, plus 0. Why 0? Because O2 is the element. And don't forget what first rule we have seen. We have seen first rule is standard enthalpy of formation. Standard enthalpy of formation of any element is 0. Here O2 is the oxygen element. O2 indicates oxygen element present in diatomic form. कार्बन एटॉमिक फॉर्म में इसलिए हमने C लिया था, लेकिन क्लोरीन डायटोमिक फॉर्म में होता है, तो Cl2 का मतलब क्लोरीन एलिमेंट इन डायटोमिक फॉर्म. O2 का मतलब क्या? ऑक्सीजन एलिमेंट इन डायटोमिक फॉर्म. H2 हाइड्रोजन एलिमेंट इन डायटोमिक फॉर्म. N2 नाइट्रोजन एलिमेंट इन डायटोमिक फॉर्म. So standard enthalpy of formation of Cl2 or N2 or H2 or O2 or C with 0. Standard enthalpy of formation of any element is 0. So 0 I. Just by putting the values, final answer is standard enthalpy of reaction delta HR0. Delta HR0 is minus 3119 किलोजूल. ओके, हमने देखा है कि जो स्टैंडर्ड एंथैल्पी ऑफ रिएक्शन हमेशा किसमें होता है, किलोजूल में होता है. यूनिट क्या आएगा, किलोजूल. गो टू द नेक्स्ट स्लाइड. ओके, stop here because I have planned different topics from next time. So students, thank you very much. Got to stop here.